Picture a galaxy so strange, so utterly unlike anything else in the cosmos, that it looks like it was hurled into space by the hand of a cosmic giant. The Cartwheel Galaxy, a sprawling, hypnotic ring of stars and dust, is one of the most bizarre structures ever discovered in the universe. Its very shape defies explanation, a perfect ripple of light stretching across the darkness, as if someone dropped a stone into a pond made of stars. But the strangeness doesn't stop there. Hidden within its swirling arms and glowing core are phenomena so peculiar, so downright mysterious, that even the brightest minds in astronomy are left scratching their heads. What is happening inside this celestial oddity, and why does it seem to break the rules of physics as we know them? This isn't just another distant galaxy. The Cartwheel is a cosmic crime scene, a place where the usual laws of the universe appear to have been twisted, warped, or outright ignored. Some of its secrets are written in the language of gravity. Black holes behaving in ways they shouldn't, stars vanishing without a trace, and entire regions of space where time itself might be moving differently. Others are etched in light, with bursts of energy so intense they could rewrite our understanding of how galaxies evolve. And then there are the things we can't explain at all, glowing anomalies with no known source, structures that shouldn't exist, and signals that hint at forces beyond our wildest theories. That's exactly why we're diving deep into the Cartwheel Galaxy today. Over the next 30 discoveries, we'll uncover the most jaw-dropping, spine-tingling, and utterly baffling phenomena lurking within this cosmic enigma. From rogue planets drifting through its rings to the whispers of dark matter pulling its strings, each mystery will leave you questioning how much we truly know about the universe. So buckle up, because by the time we're done, you'll never look at the night sky the same way again. The Cartwheel Galaxy isn't just a spectacle, it's a puzzle waiting to be solved. And the deeper we go, the stranger it gets. The first thing you notice about the Cartwheel Galaxy is the sheer impossibility of its shape. Most galaxies, like our own Milky Way, are elegant spirals or lumpy, amorphous blobs. But this one, it looks like someone tossed a stone into a cosmic pond, sending perfect ripples of stars cascading outward. That massive, luminous ring stretching 500,000 light-years across isn't just unusual, it's a cosmic anomaly, a structure so rare that astronomers still argue over how it could exist at all. The leading theory, a violent head-on collision. Picture a smaller galaxy, something like our own, plunging straight through the heart of the Cartwheel hundreds of millions of years ago. The impact would have sent shockwaves through the galaxy's gas and dust, compressing them outward like ripples in water. Those compressed regions then ignited with new star formation, creating the brilliant ring we see today. It's the universe's version of a pebble dropping into a still lake, only instead of water, it's a tsunami of stars. But here's where things get weirder. Most collision-shaped rings eventually fade, their structure blurring back into chaos over time. Yet the Cartwheel's ring remains crisp, almost unnervingly perfect. It's as if someone hit pause on the aftermath of that ancient crash, freezing the galaxy in this strange, suspended state. Some researchers think dark matter might be warping the galaxy's gravity, holding its shape unnaturally in place. Others suggest there's something fundamentally different about how the Cartwheel stars and gas behave, as if the rules of physics there are just slightly off. Then there's the mystery of the ring's composition. Unlike most galaxies where star formation happens gradually, the Cartwheel's outer ring is a fireworks show of newborn stars blazing with furious energy. Meanwhile, its inner regions are eerily quiet, almost dormant. It's like catching a galaxy mid-transformation, half frozen in the past, half exploding into an unknown future. Astronomers can't even agree if the ring is still expanding or if it's locked in some impossible equilibrium. What makes this even more baffling is that the Cartwheel isn't alone. A handful of other ring galaxies exist, but none as pristine or as massive. It's as if we're witnessing a cosmic accident so rare, so finely balanced that it shouldn't have survived this long. And that's the real puzzle, not just how this bizarre structure formed, but why it hasn't unraveled yet. Every observation raises new questions, and with each answer, the Cartwheel Galaxy only becomes more mysterious. The Cartwheel Galaxy doesn't just defy expectations with its shape, it breaks the rules when it comes to making stars, too. While most galaxies produce new stars at a steady, almost leisurely pace, the Cartwheel's outer ring is a frenzy of stellar birth, churning out massive, blazing suns at a rate that should be impossible. Imagine a fireworks display where every explosion triggers another. Louder burst, that's what star formation looks like here, a runaway chain reaction lighting up the cosmos. What makes this even stranger is how it clashes with everything we know about how stars form. Normally, dense clouds of gas slowly collapse under their own gravity, heating up until nuclear fusion ignites. But in the Cartwheel's outer ring, the process is turbocharged. Gas clouds there are so violently compressed, likely by the shockwaves from that ancient collision, that stars are born in crowded, chaotic clusters, some with masses dozens of times greater than our Sun. These aren't just stars, they're cosmic monsters, burning bright and dying young in spectacular supernovae that seed the ring with even more raw material for future stars. This frenzy poses a glaring question. Why hasn't the galaxy run out of fuel? Normally, such extreme starbursts would deplete their gas reserves within a few 100 million years. Yet the Cartwheel's ring keeps burning as if someone left the cosmic faucet on. Some theories suggest gas is being funneled inward from the galaxy's outskirts, or even stolen from nearby companion galaxies. Others propose that the galaxy's unique structure traps gas in the ring, recycling it through supernova explosions and stellar winds. But no model perfectly explains the sheer scale of what's happening. Then there's the mystery of timing. The bursts aren't constant. They come in waves as if the galaxy is breathing in and out. Some regions suddenly flare with newborn stars while others go eerily quiet. It's almost like the Cartwheel has a heartbeat, pulsing with bursts of creation we can't yet predict. Astronomers have even spotted star-forming knots, tight, glowing clumps where thousands of stars ignite at once, crammed into spaces smaller than the distance between the Sun and its nearest stellar neighbor. The most unsettling part, these surges might be rewriting the story of how galaxies evolve. The Cartwheel's violent star-making seems to skip steps, creating conditions we've only seen in the early universe when galaxies were young and the cosmos was a far wilder place. It's as if we've found a relic of that ancient chaos, a galaxy frozen in time, yet somehow still alive with fireworks. Every new observation leaves us wondering, is the Cartwheel showing us the past or hinting at a future we don't yet understand? At the heart of the Cartwheel Galaxy's swirling chaos lies a paradox, a supermassive black hole that refuses to follow the rules. Most galaxies hide voracious monsters in their cores, devouring surrounding matter and unleashing torrents of energy. But the Cartwheel's central black hole is eerily subdued, a sleeping giant amidst a storm of stellar fireworks. It's like finding a silent, darkened engine room in the middle of a roaring factory. Its quietness defies everything we know about how black holes behave. What makes this so baffling is the sheer contrast. The galaxy's outer ring is a maelstrom of star birth and explosive energy, yet its core emits barely a whisper of activity. Normally, supermassive black holes feed on gas and dust, heating their surroundings to extreme temperatures and blasting out jets of radiation. But here, the black hole seems to be on a cosmic diet. Some astronomers call it undernourished, as if the galaxy's violent collision stripped away its usual meal ticket. One theory suggests the impact that formed the Cartwheel's iconic ring might have flung most of the gas outward, starving the core. Picture a dinner plate being yanked away mid-meal, except this plate was a galaxy's worth of fuel. Another idea hints at dark matter's influence, with invisible forces somehow stabilizing the black hole's appetite. There's even speculation that the black hole isn't quiet at all, but its emissions are being redirected or masked by the galaxy's unique structure, like a spotlight shining away from Earth. The real shock came when researchers compared it to other ring galaxies. Most show heightened black hole activity, feeding frenzies triggered by the same collisions that shaped them. But the Cartwheel's core is an exception, a rebel that challenges textbook assumptions. Could its stillness be temporary, a lull before some catastrophic reawakening? Or is this black hole fundamentally different, operating by rules we haven't uncovered yet? Every observation deepens the puzzle. Some data hints at faint, sporadic outbursts, flares of activity too brief to fit any known pattern. Others suggest the black hole might be flickering, alternating between dormancy and subtle feeding in cycles we can't yet predict. It's as if we're watching a cosmic heartbeat, faint but persistent, in a place where silence should be impossible. This isn't just a quirk of one galaxy. If the Cartwheel's black hole truly defies expectations, it could rewrite our understanding of how these cosmic titans evolve. Are quiet black holes more common than we thought? Do collisions sometimes put them to sleep instead of waking them up? The answers might lie hidden in the Cartwheel's core, waiting to reveal secrets that could change how we see the universe itself. Just when you thought the Cartwheel Galaxy couldn't get any stranger, it starts talking, or at least broadcasting, signals that no one can decipher. Among its many mysteries are unexplained radio emissions, bursts of energy crackling through the void that defy every known source in the cosmos. These aren't your typical radio waves from pulsars or quasars. They're erratic, unpredictable, and packed with patterns that make astronomers question whether we're missing an entire chapter in the book of cosmic physics. At first glance, these emissions resemble the faint whispers of neutron stars, dense, spinning remnants of dead suns that pulse like lighthouses across the universe. But the Cartwheel's signals don't match any known neutron star behavior. They flicker on and off at irregular intervals, sometimes vanishing for years before flaring back to life with renewed intensity. It's as if something inside the galaxy is deliberately toying with the volume knob, cranking it up and down in no discernible rhythm. Some researchers have proposed the idea of orphaned neutron stars, ones flung into the galaxy's outer reaches by ancient collisions, spinning wildly in isolation. Yet even that theory fails to explain the sheer randomness of the signals. Then there's the spectral fingerprint of these waves. Unlike the clean, predictable frequencies emitted by most cosmic objects, the Cartwheel's radio bursts are smeared with odd harmonics and shifting wavelengths. It's like tuning a radio and catching snippets of a dozen stations at once, none of them quite in focus. One leading hypothesis suggests these distortions could come from clouds of exotic matter, particles or forces we haven't yet discovered, interacting with the waves as they travel through the galaxy. Imagine light passing through a prism, but instead of bending into a rainbow, it fractures into something unrecognizable. The most tantalizing and unsettling possibility is that we're hearing the echoes of an entirely new astrophysical phenomenon. Some astronomers have floated the idea of magnetars on steroids, neutron stars with magnetic fields so intense they warp the fabric of space-time around them. Others speculate about primordial black holes, tiny yet incredibly dense relics from the birth of the universe, threading through the galaxy's gas and sparking these bizarre emissions as they go. There's even a fringe theory that the Cartwheel might be hiding a quasar remnant, the dying echo of a once ferocious galactic nucleus, now fading but still capable of strange outbursts. What's undeniable is that these radio waves challenge the boundaries of our knowledge. Every time we point a telescope at the Cartwheel, it seems to throw another curveball, whispering secrets in a language we don't yet understand. Whether it's undiscovered physics, hidden objects, or something even more extraordinary, one thing's clear: the universe is far weirder than we ever imagined, and the Cartwheel Galaxy is its most enigmatic storyteller. The Cartwheel Galaxy isn't just playing tricks with light and radio waves, it's also defying the very fabric that holds the universe together. Dark matter, the invisible glue that binds galaxies, seems to be missing here. Or at least not where it's supposed to be. Observations reveal a startling mismatch: the galaxy's gravitational pull, the way its stars move, even the structure of its iconic ring, all suggest far less dark matter than our best cosmological models predict. It's like stepping on a scale and realizing you weigh half what physics says you should. This isn't just a minor discrepancy. Dark matter is the scaffolding of the cosmos, the hidden force that dictates how galaxies form and evolve. Without it, the Cartwheel's delicate ring structure should have collapsed eons ago, torn apart by the chaotic motions of its stars. Yet somehow it persists, its perfect loops defying gravity's expectations. Some researchers argue the collision that shaped the galaxy might have flung dark matter outward, scattering it like dust in a cosmic wind. Others propose something even wilder: that the Cartwheel exists in a pocket of the universe where dark matter behaves differently, its influence weaker or stranger than we've ever seen. The most radical theories go further. Could the galaxy be filled with an unknown type of dark matter, one that interacts differently with ordinary matter? Or is dark matter itself more dynamic than we thought, capable of clumping or evaporating under extreme conditions? The Cartwheel's defiance forces us to reconsider foundational assumptions. If dark matter isn't playing by the rules here, how many other galaxies might be hiding similar secrets? What makes this puzzle even thornier is the ghostly evidence lurking at the galaxy's edges. Faint streams of stars stretched like taffy hint at gravitational forces we can't entirely account for. Some computer simulations suggest these could be trails of lost dark matter, faint echoes of what was once there. But without direct detection, the mystery deepens. The Cartwheel isn't just challenging our maps of the cosmos, it's hinting that the map itself might be wrong. And that's the real stakes of this enigma. If the Cartwheel's missing dark matter isn't an anomaly but a clue, it could rewrite our understanding of how galaxies are born, live, and die. Perhaps dark matter isn't the uniform, predictable force we've assumed. Perhaps it's as dynamic and varied as the galaxies it shapes. Until we solve this riddle, the Cartwheel remains a cosmic rebel, quietly proving that the universe still holds cards it hasn't shown us. If you think the Cartwheel Galaxy has shown all its cards, think again. Wrapped around its glowing rings like invisible scars are eerie, looping filaments of X-ray light structures so faint they were almost missed entirely. These ghostly arcs don't match anything else in the galaxy, shimmering with energy that shouldn't persist for so long. It's as if the galaxy is wrapped in cosmic barbed wire, radiating secrets only certain wavelengths can reveal. The leading explanation points to shockwaves from ancient supernova, stellar explosions so powerful they sent ripples through the galaxy's gas, heating it to millions of degrees. Picture a stone dropped in water, but instead of gentle ripples, imagine a tsunami of energy carving permanent loops into the fabric of space. These X-ray loops could be the aftermath of a chain reaction, where one dying star triggered another in a domino effect of violence. Yet there's a problem. Most supernova remnants fade within tens of thousands of years. These loops, they stretch for hundreds of thousands of light years, defying time itself. Another theory suggests they're the fingerprints of collisions we can't see. Invisible clouds of gas, perhaps dark matter clumps, slamming into the galaxy's outer edges. The energy from these impacts would heat the gas, making it glow in X-rays. It's like watching smoke rise from an unseen fire, hints of a struggle happening just beyond our perception. Some models even propose these loops are cosmic lassos, magnetic fields twisted and stretched by the galaxy's spin until they snap, releasing bursts of high-energy radiation. The strangest part, these loops aren't static. They shift subtly over time, as if alive. Recent observations show some sections brightening while others dim, a behavior no existing model fully explains. Are we seeing the galaxy's magnetic field rearrange itself, or evidence of something more exotic, like hidden black holes spraying jets of particles into the void? One thing's certain, these X-ray loops are more than just cosmic graffiti. They're a puzzle wrapped in an enigma, a reminder that even the quietest corners of the Cartwheel Galaxy hum with mysteries we've only begun to uncover. Every new clue pulls us deeper into the unknown, where the answers might rewrite not just the story of this galaxy, but of the universe itself. The Cartwheel Galaxy's spiral arms don't just curve gracefully through space. They twist and shatter like broken glass, their fragments scattered in chaotic arcs. While most spiral galaxies boast symmetrical arms winding outward like clockwork, the cartwheels are jagged, warped, as if someone grabbed the galaxy's edges and gave them a violent shake. This isn't just cosmetic damage, it's a cosmic fingerprint, evidence of forces so extreme they've permanently bent the galaxy's skeleton, the most obvious culprit. That ancient collision thought to have birthed the galaxy's iconic ring. When a smaller galaxy plowed through the cartwheel's core, it didn't just send shockwaves through its gas, it yanked the very fabric of the galaxy out of shape. Picture throwing a rock into a spiderweb. The threads don't just ripple, they snap, tangle, and fray. That's what happened here, with gravitational tides stretching the arms into irregular clumps and leaving behind trails of stars adrift like cosmic debris. But there's more to the story. Nearby galaxies small, hungry companions continue to tug at the cartwheel's arms like invisible hands. Their gravity peels away loose stars and gas, further distorting the already fractured structure. Some fragments even seem to orbit backward, moving against the galaxy's spin as if caught in a celestial riptide. It's as if the cartwheel is stuck in a gravitational tug of war, its arms pulled in multiple directions at once. What's truly baffling is how long this disruption has lasted. Most galaxies smooth out after collisions, their structures reforming over millions of years. Yet the cartwheel's arms remain stubbornly fractured, frozen in disarray. Some researchers speculate dark matter might be anchoring the chaos, its invisible grip preventing the galaxy from healing. Others wonder if we're witnessing a new kind of galactic evolution, one where damage isn't temporary but a permanent state of being, the final twist. These distorted arms might hold the key to the galaxy's future. Their fragmented gas clouds are prime real estate for new stars, meaning the very forces tearing the cartwheel apart could also be fueling its rebirth. It's a cosmic paradox, destruction and creation locked in an endless dance. And with every telescope pointed its way, the cartwheel reminds us that in the universe, even chaos has a purpose. Deep within the Cartwheel Galaxy's tangled arms, something is firing bullets into the cosmos, particles moving so fast, so violently, they defy every known law of physics in this region of space. These aren't just ordinary cosmic rays, they're ultra-high-energy projectiles, packing enough punch to make even the most seasoned astrophysicists double-check their instruments. The mystery isn't just their power, it's where they're coming from. The cartwheel shouldn't have the right conditions to produce these kinds of particles. Yet they're here, streaking through the void like cosmic cannon fire, and no one can explain why. The numbers alone are staggering. Some of these particles carry energies exceeding 100 exa-electron volts, millions of times more powerful than anything produced in Earth's particle accelerators. At those intensities, they should only come from the universe's most extreme environments. The hearts of quasars, the wakes of colliding galaxy clusters, or the shock waves of supermassive black holes. But the cartwheel, for all its strangeness, lacks these obvious powerhouses. Its central black hole is eerily quiet, and its outer regions, while turbulent, don't show the kind of large-scale violence needed to crank particles up to such absurd energies. So what's launching them? One theory points to hidden pulsars rapidly spinning neutron stars with magnetic fields trillions of times stronger than Earth. These cosmic dynamos could, in theory, accelerate particles to extreme speeds along their poles like cosmic slingshots. But there's a catch. Pulsars usually emit predictable, rhythmic pulses of radiation. The Cartwheel's high-energy particles arrive in chaotic bursts with no detectable pattern. Some researchers speculate these might be rogue pulsars, ones kicked into erratic motion by ancient collisions, their beams wobbling wildly as they tumble through space. Others suggest something even more exotic, a cluster of magnetars neutron stars with magnetic fields so intense they distort the fabric of space-time, working in tandem to create a particle accelerator of unimaginable scale. Then there's the black hole angle. While the Cartwheel's central supermassive black hole might be dormant, smaller, stellar mass black holes could be lurking in its outer reaches. If these smaller black holes are feeding, swallowing gas or even stars, their accretion disks could generate jets of particles moving at near light speed. Normally, such jets would be visible in radio or X-ray wavelengths, but the Cartwheel's tangled magnetic fields might be bending or masking them, leaving only these high-energy particles as clues. The most tantalizing and unsettling possibility is that we're seeing the fingerprints of an entirely new type of cosmic accelerator. Some models hint at dark matter interactions, where invisible particles collide and annihilate, releasing bursts of energy that could propel ordinary matter to extreme velocities. Others raise the specter of primordial defects in space-time, leftover wrinkles from the Big Bang acting like cosmic trampolines, kicking particles to speeds physics says shouldn't be possible here. What's clear is that the Cartwheel Galaxy isn't just breaking rules, it's rewriting them. Every time we detect one of these ultra-high-energy particles, it's like receiving a message from a universe we don't fully understand, a reminder that the cosmos still holds engines of power beyond our wildest theories. Whether it's hidden pulsars, rogue black holes, or something even stranger, the Cartwheel's particle enigma challenges us to rethink what's possible in the silence between the stars. One of the Cartwheel Galaxy's most striking and puzzling features isn't just in its ring or fractured arms, but in a shimmering, ethereal halo of blue light encircling its outer edges. This blue glow isn't supposed to be there. Galaxies like this, shaped by violent collisions, usually fade into faint, reddish halos of older stars at their peripheries. But the Cartwheel's halo burns with the unmistakable hue of youth, massive, hot, blue stars shining where theory says they shouldn't exist. It's like finding a nursery full of newborns in a retirement home, a cosmic contradiction that challenges everything we know about where stars form. The blue halo's existence throws a wrench into conventional models of galactic evolution. Young, blue stars typically live fast and die young, burning through their fuel in tens of millions of years rather than billions. They're born in dense gas clouds, usually clustered in a galaxy's busy spiral arms or starburst regions, not drifting alone in the quiet outskirts. Yet here they are, sprinkled across the Cartwheel's halo like sapphire dust, defying the odds. Where did they come from, and how are they surviving in what should be a stellar dead zone? One leading theory suggests these stars were ripped from smaller galaxies during ancient mergers. Picture the Cartwheel as a cosmic spider, its gravitational web tearing apart, passing dwarf galaxies and scattering their star-forming gas across its halo. The violence of those encounters could have triggered isolated bursts of star formation, leaving behind these blue stragglers like breadcrumbs from a long-forgotten feast. Supporting this idea are faint stellar streams, ghostly ribbons of stars woven through the halo, possible remnants of those devoured galaxies. But there's a problem. Some of the blue stars appear too evenly distributed, too organized to be the messy aftermath of collisions. This has led to a radical alternative, that the Cartwheel's halo is somehow creating stars on its own, without the dense gas clouds we thought were necessary. Could turbulence from the galaxy's violent past have stirred up trace amounts of hydrogen, allowing stars to form in the cosmic equivalent of a desert? Or is there an unknown mechanism at work, something that lets stars ignite in conditions we've never observed elsewhere? The most tantalizing clue lies in the halo's chemistry. Spectroscopic data reveals these stars are oddly rich in heavy elements, suggesting they formed from gas already polluted by previous generations of stars. That's hard to reconcile with the merger theory, as swallowed dwarf galaxies are usually metal-poor. Instead, it hints at a process where gas ejected from the Cartwheel's inner regions, perhaps by supernova winds, drifted outward, cooled, and coalesced into new stars far from the galactic center. It's as if the galaxy is breathing out its own building blocks, seeding its halo with the ingredients for unexpected starlight. What makes this enigma even more profound is its implications for how galaxies evolve. If the Cartwheel's halo can birth stars in isolation, it could mean we've underestimated the versatility of star formation and overlooked similar halos in other galaxies. Or perhaps this is a fleeting phenomenon, a brief blue flash in the cosmic dark, unique to galaxies caught in the aftermath of catastrophe. Whatever the answer, the Cartwheel's halo isn't just a pretty anomaly, it's a challenge to our understanding of how stars and the galaxies they light up are born, live, and rewrite the rules of the universe. Astronomers watching the Cartwheel Galaxy recently caught something bizarre: sudden, unexplained flares of infrared light erupting from its depths without warning. These aren't the gentle flickers of distant stars, but violent bursts, as if someone had switched on a cosmic furnace inside the galaxy, heating dust clouds to searing temperatures in a matter of days. What's strangest isn't just the intensity of these flares, it's their randomness. Unlike supernova, which build to a climax, or quasars, which glow steadily, these infrared spikes appear and vanish like cosmic Morse code, leaving behind more questions than answers. The leading suspect, hidden supernova. When massive stars explode, they flood their surroundings with heat, lighting up nearby dust like a match to paper. But the Cartwheel's flares don't quite fit the pattern. Most supernova leave behind visible traces, expanding shockwaves, lingering X-rays, yet these bursts fade too quickly, leaving no visible aftermath. It's as if the galaxy is hosting supernova that detonate behind a curtain, their explosions absorbed entirely by thick veils of dust before we can glimpse the source. Then there's the black hole angle. Though the Cartwheel's central supermassive black hole is unusually quiet, smaller, hidden black holes might lurk in its spiral arms. If one of these suddenly gulped down a star or a gas cloud, the resulting feeding frenzy could heat surrounding dust to incandescence, flaring bright in infrared before fading into obscurity. But even this theory stumbles. The flare's locations shift unpredictably, as if the galaxy's hidden engine is moving or multiple engines are firing at once. The most tantalizing possibility, something entirely new. The flare's erratic timing and the Chinese letter defy known astrophysical processes, hinting at phenomena we've yet to categorize. Some researchers speculate about dust avalanches, rare chain reactions where collapsing dust clouds trigger neighboring ones to heat up in rapid succession like dominoes of light. Others wonder if the Cartwheel's unique structure funnels radiation in ways that amplify small events into brilliant, fleeting bursts. What's undeniable is that these flares challenge our understanding of how energy moves through galaxies. Most cosmic events leave trails, clues we can follow. But the Cartwheel's infrared bursts are ghosts, here one moment and gone the next, as if the galaxy itself is playing a game of celestial hide and seek, and we're only beginning to learn the rules. Among the Cartwheel Galaxy's many enigmas, few are as baffling as its disappearing hydrogen clouds, vast reservoirs of gas that vanish between observations like cosmic ghosts. These aren't just small, wispy formations. We're talking about massive clouds, some spanning hundreds of light years, packed with enough raw material to birth thousands of stars. One year they're there, glowing faintly in radio telescopes, the next gone without a trace. Then, inexplicably, they might reappear decades later, as if the galaxy itself is playing a shell game with its own building blocks. The leading theory points to something dark and unseen, literally. Cold, dense clumps of gas or even rogue black holes could be drifting through the Cartwheel's outer reaches, absorbing hydrogen as they pass. Picture a sponge moving through water, soaking up everything in its path. If these objects are dark enough, they'd be invisible to telescopes, leaving no trace except the sudden absence of the gas they've swallowed. The problem: even the hungriest black holes or coldest gas pockets shouldn't be able to consume entire clouds so quickly, or leave so little evidence behind. Then there's the measurement mystery. Hydrogen emits a faint radio signal at a very specific wavelength, which astronomers use to map its presence. But if something, say, intense magnetic fields or turbulent gas motions, were to scramble that signal, the clouds might appear to vanish when they're simply hiding in plain sight. It's like tuning a radio to a station that suddenly switches frequencies. The music's still playing, but you can't hear it anymore. Some researchers argue the Cartwheel's chaotic environment could be doing exactly that, warping or dispersing the hydrogen signature until it's undetectable. The plot thickens with the clouds' reappearances. When they pop back into view, they often look different, stretched, fragmented, or shifted in ways that suggest they've been violently disturbed. One controversial idea is that the galaxy's magnetic field is acting like a cosmic funhouse mirror, twisting and compressing the gas until it's temporarily invisible, then releasing it in altered form. Others propose these clouds aren't vanishing at all but migrating, sinking into the galaxy's denser regions where they're harder to spot, only to be flung outward again by some unseen force. What's truly unsettling is the scale of these disappearances. If entire gas clouds can blink out of existence, even temporarily, it raises questions about how accurately we understand the universe's most abundant element. Hydrogen is the lifeblood of galaxies, the raw material for stars and planets. If it can vanish without a trace or reappear without warning, it challenges our assumptions about how galaxies evolve, how they breathe, and even how they die. The Cartwheel's disappearing act isn't just a curiosity. It's a cosmic whisper, hinting that the rules we've written for the universe might be missing a few pages. In the midst of the Cartwheel Galaxy's star-studded chaos, astronomers have stumbled upon a cosmic anomaly that defies all expectations. A vast, starless void where red giants should thrive. Dubbed the Red Gap, this region is eerily absent of the aging, bloated stars that dominate similar galactic neighborhoods. It's like walking into a forest and finding a clearing where every tree is inexplicably young, with no trace of the ancient giants that should tower overhead. Red giants are the universe's retiree stars that have burned through their hydrogen fuel and now swell into glowing behemoths as they near the end of their lives. In most galaxies, they're as predictable as gravity itself, yet in the Cartwheel's Red Gap, they're conspicuously missing. Stellar population models, which map how stars age and distribute over time, insist this region should be teeming with them. Instead, it's a desert of youth populated by smaller, hotter stars, as if some unseen hand plucked out every elder star and left only the newborns behind. So what could have caused this stellar vanishing act? One theory suggests the galaxy's violent collision didn't just reshape its structure, it might have reset its stellar clock. The shockwaves from that impact could have triggered such a furious wave of new star formation that it effectively overwrote the older population, leaving behind a generation of stars all born around the same time. Imagine a fireworks show so intense it drowns out every other light in the sky, except here, the fireworks are stars and their brilliance has outshone the galaxy's past. But there's a catch. Even in starburst galaxies where star formation runs rampant, red giants don't just disappear. They linger as cosmic elders, their presence a record of earlier eras. The red gap's utter lack of them suggests something more extreme, perhaps a tidal force so powerful it ripped away the older stars entirely. Nearby companion galaxies could be the culprits, their gravity acting like a cosmic sieve, funneling away the slower-moving red giants while leaving younger, faster stars behind. The most unsettling possibility, the red gap isn't a gap at all but a shadow. Some researchers speculate that thick dust clouds expelled during the Cartwheel's collision might be obscuring our view of the red giants, absorbing their light before it reaches our telescopes. If true, the region could be hiding a ghostly population of stars we simply can't see, a cosmic game of hide and seek played out on a galactic scale. Whatever the explanation, the red gap forces us to confront a humbling truth. Our models of how galaxies age might be missing a crucial piece. The Cartwheel's defiance could be a fluke, or it could be a clue hinting at processes we've yet to imagine. Until we solve this puzzle, the galaxy's silent clearing stands as a reminder that even the most fundamental rules of the cosmos are still being written. Among the Cartwheel Galaxy's many cosmic oddities, one pattern stands out as particularly eerie. Its neutron stars spin in uncanny alignment, like a fleet of clocks all ticking in perfect rhythm. These ultra-dense stellar corpses, typically scattered in random orientations across the universe, here appear to share a mysterious synchrony, their rotational axes pointing in roughly the same direction. It's as if some unseen hand reached into the galaxy and twisted them into formation, leaving astronomers to wonder, is this a fluke or the ghostly imprint of a catastrophic past event? Neutron stars aren't just any cosmic objects. Born from the explosive deaths of massive stars, they pack more mass than our Sun into a sphere barely the size of a city, spinning at dizzying speeds while emitting beams of radiation like interstellar lighthouses. Normally, their spin axes point where chance dictates, shaped by the chaotic forces of their parent star's collapse. But in the Cartwheel, multiple neutron stars, some separated by thousands of light years, show a peculiar preference for alignment. Statistical models suggest the odds of this happening randomly are vanishingly small, hinting at something deeper at work. One explanation points to the galaxy's violent origin. If the collision that shaped the Cartwheel sent shockwaves through its magnetic field, those forces could have acted like a cosmic comb, brushing the neutron stars into alignment as they formed. Imagine a magnet stirring a bowl of iron filings, except here, the filings are city-sized stellar corpses, and the magnet is a galaxy-wide magnetic field trillions of times stronger than Earth. Supporting this idea are traces of an unusually ordered magnetic field threading the Cartwheel's rings, a possible relic of the impact that could have orchestrated this synchronization. Then there's the black hole hypothesis. Some theorists propose the galaxy's central supermassive black hole, though quiet now, might have once unleashed jets of particles spinning with such energy that they dragged nearby neutron stars into alignment like leaves caught in a whirlpool. If true, these neutron stars could be fossils of that long-ago outburst, their orientations frozen in time like arrows pointing to an ancient catastrophe. But the most tantalizing possibility is that we're seeing the aftermath of a collective event. A moment when the Cartwheel's neutron stars were all subjected to the same gravitational or magnetic trauma. Perhaps a passing galaxy or cluster yanked on them simultaneously, or a wave of dark matter distortion swept through, nudging them into sync. The implications are profound. If external forces can align neutron stars on galactic scales, it might mean we've underestimated how interconnected cosmic objects truly are. The Cartwheel's aligned neutron stars aren't just a curiosity, they're a cosmic puzzle box, one that might hold clues to how galaxies transmit influence across vast distances. Whether it's magnetism, gravity, or something even stranger, their silent coordination whispers of hidden forces weaving order into the chaos of the universe. And until we crack their code, they'll keep spinning in unison, a silent chorus of dead stars singing a song we're only beginning to hear. Hidden within the Cartwheel Galaxy's spiral arms, astronomers have pinpointed something that shouldn't exist: glowing patches of gamma rays, blazing with the energy of 1 billion suns, yet tied to no visible object. These hotspots aren't just bright, they're concentrated, almost surgical in their placement, as if someone had taken a cosmic blowtorch to specific corners of the galaxy. Gamma rays, the universe's most energetic light, typically come from violent sources, colliding neutron stars, supermassive black holes, or the remnants of supernova. But these no known cause fits. It's like finding a dozen bonfires in a forest, each burning fiercely with no sign of who lit them. One explanation sends shivers down the spines of physicists: dark matter annihilations. If dark matter is made of exotic particles, the kind that destroy each other on contact, their collisions could unleash torrents of gamma rays. The Cartwheel's hotspots might be the graveyards of these invisible particles, their final moments lighting up the void. It's a tantalizing idea, but there's a catch. These gamma ray patches don't match the predicted patterns for dark matter. They're too clustered, too specific, as if something else is directing the show. Then there's the microquasar theory. Microquasars are stellar mass black holes or neutron stars with jets powerful enough to mimic their supermassive cousins, just on a smaller scale. Normally, their gamma-ray signatures are faint and diffuse, but if the Cartwheel harbors a swarm of them, hidden, hyperactive, and far more energetic than any we've seen, their combined jets could carve out these intense hotspots. The trouble: no telescope has spotted the telltale X-rays or radio waves that microquasars should emit alongside gamma rays. It's as if the galaxy is hosting invisible cosmic blowtorches, radiating nothing but the most extreme light. The plot thickens with the hotspots' locations. They aren't scattered randomly. Many trace the edges of the galaxy's iconic ring, clinging to regions where shockwaves from the ancient collision still ripple through the gas. Some researchers think these shock fronts might be acting like natural particle accelerators, ramping up stray electrons to near light speeds until they slam into photons, transforming them into gamma rays. If true, the Cartwheel could be a colossal cosmic lab, demonstrating physics we've only simulated in theory. But the real mystery lies in the outliers' hotspots floating far from the ring, untethered to any visible structure. These rogue emissions defy even the most creative theories. Could they be scars from past stellar cataclysms, their origins long faded, or echoes of something stranger, like primordial black holes evaporating into bursts of radiation? Every explanation leaves gaps, and every observation deepens the enigma. What's clear is that the Cartwheel's gamma-ray hotspots aren't just cosmic curiosities. They're clues pointing to processes we've never witnessed or particles we've yet to discover. Whether it's dark matter's fingerprints or the galaxy's hidden engines at work, one thing's certain: the Cartwheel isn't just breaking the rules. It's daring us to rewrite them. Nestled along one of the Cartwheel Galaxy's twisted arms, a celestial necklace glimmers. A straight, shimmering line of star clusters so perfectly spaced they look strung together by cosmic hands. Astronomers call it the String of Pearls, a formation that defies the usual chaos of galactic collisions. Each pearl is a massive young star cluster, blazing with blue-white intensity, while the invisible thread connecting them stretches thousands of light years without a single kink or curve. It's as if the galaxy, in the midst of its turmoil, paused to craft something impossibly precise. The most straightforward explanation points to a tidal tail, a ribbon of stars and gas yanked outward during the Cartwheel's ancient collision. When galaxies collide, gravitational forces can stretch their material into long, streamer-like structures, often littered with pockets of new star formation. But the String of Pearls doesn't behave like a typical tidal tail. Those are usually messy, warped by the galaxy's rotation or the pull of neighboring objects. This formation is freakishly linear, as if drawn with a ruler. Even stranger, the clusters are nearly identical in size and brightness, spaced at eerily regular intervals, more like a manufactured pattern than a random cosmic accident. That's led to a wilder theory, gravitational resonance. Just as a vibrating guitar string produces harmonic notes, a galaxy's gravitational field can create nodes where gas and stars accumulate in predictable spots. The Cartwheel's violent past might have set off waves of compression that lined up these nodes like beads on a string. Supporting this idea are computer simulations showing how shockwaves from the collision could have rippled through the galaxy's gas, creating stable pockets where stars ignited in unison. It's the universe's version of a standing wave, freezing a moment of chaos into perfect order. Yet there's a twist. Some of the pearls aren't just young clusters. They're surrounded by faint, older stars, suggesting this structure might have existed before the Cartwheel's collision. That raises the spine-tingling possibility that the string of pearls is a relic of something even older, a fossilized filament from the galaxy's earliest days. Could it be a scar from a near miss with another galaxy, a gravitational braid left behind as they passed, or the shadow of a dark matter tendril, its invisible gravity herding stars into this uncanny alignment? The deeper astronomers look, the more questions arise. Infrared observations reveal dust lanes weaving between the pearls, hinting at hidden flows of material still feeding the clusters. Radio telescopes detect faint magnetic fields threading through the string, as if the galaxy is stitching it into place. And then there's the mystery of the gap spaces between pearls where nothing seems to form, as if some invisible barrier keeps stars from igniting there. What makes the string of pearls truly extraordinary isn't just its beauty. It's the way it challenges our understanding of how structure emerges in the universe. Most cosmic patterns are shaped by chaos, but this one whispers of hidden order, a delicate balance between destruction and design. Whether it's a tidal tale frozen in time, a gravitational echo, or something even stranger, one thing's certain: the Cartwheel Galaxy didn't just break the mold, it strung the pieces together and dared us to unravel how. The Cartwheel Galaxy doesn't just harbor strange structures and violent bursts of energy. It's also home to stars that move like they've been fired from a cosmic cannon. Scattered across its rings and arms are rogue suns hurtling through space at speeds that defy logic, some clocking in at thousands of kilometers per second faster than their neighbors. These aren't just slightly faster stars, they're outright fugitives, racing so fast they should have escaped the galaxy's gravity entirely. Yet somehow they remain bound to the Cartwheel, streaking through its depths like bullets caught in an endless loop. The mystery lies in how they got so fast. Normally, stars move at predictable speeds dictated by their galaxy's gravitational pull, like cars cruising on a celestial highway. But these speed demons are more akin to particles in a particle accelerator, boosted to velocities that make no sense in their current environment. The leading explanation: a gravitational slingshot from the Cartwheel's violent past. When that smaller galaxy plowed through its center, the chaos didn't just reshape the galaxy. It could have sent stars pinballing off one another, flinging them forward like stones from a catapult. Picture a cosmic game of pool where the cue ball smacks into a cluster of stars, sending a few ricocheting across the table at impossible speeds. But there's a twist. Some of these runaway stars aren't just moving fast, they're veering off in unexpected directions, as if tugged by unseen forces. That's led to a more unsettling theory: rogue black holes. These invisible predators, remnants of ancient star collapses or galactic mergers, could be lurking in the Cartwheel's outskirts, their immense gravity giving passing stars a lethal kick. If one of these black holes, even a relatively small one, swung too close to a star, its pull could launch that star to blistering speeds without leaving a trace behind. It's like a ghostly hand reaching out from the darkness, swatting stars into hyperdrive. What's truly baffling is how many of these fast movers there are. Most galaxies have a handful of runaway stars, typically ejected by supernova explosions. But the Cartwheel seems to harbor entire populations of them, clustered in ways that suggest something far more systematic. Could the galaxy's unique magnetic field be acting like a particle accelerator, steadily boosting stars over time? Or is this the aftermath of a near miss with another galaxy, a close encounter that stretched and warped the Cartwheel's gravity well, leaving some stars permanently out of sync? Then there's the question of survival. Stars moving this fast should tear through the galaxy's gas clouds like meteors through atmosphere, leaving fiery trails of shock-heated plasma. Yet many show no such signs, as if they're slipping through the galaxy untouched. Some researchers think they might be that the Cartwheel's turbulent magnetic fields are creating low-resistance corridors, allowing these stars to barrel through without friction. Others speculate the stars themselves might be wrapped in protective cocoons of dense plasma, shielding them from the forces that should slow them down. The implications stretch far beyond the Cartwheel. If rogue black holes or collision dynamics can fling stars to such extremes, it could mean we've underestimated how chaotic and creative galactic evolution really is. These speeding stars aren't just curiosities, they're cosmic breadcrumbs tracing paths back to the galaxy's most violent moments. And with every new observation, the Cartwheel reminds us that even the simplest laws of motion can be bent, broken, or rewritten entirely in the right corner of the universe. At the heart of the Cartwheel Galaxy, something isn't just strange, it's downright unstable. The galaxy's core flickers like a candle in the wind, brightening and dimming in sudden, unpredictable surges. One month, it might flare with the energy of 1,000 suns. The next, it could fade to near darkness, as if a cosmic hand were toggling a switch. This isn't the steady pulse of a feeding black hole or the rhythmic glow of a quasar. It's chaos, pure and simple, and it's forcing astronomers to question everything they know about how galactic centers behave, the most obvious suspect. The galaxy's central supermassive black hole, which should be the engine behind these fluctuations. Normally, when black holes feed, they gorge on swirling disks of gas and dust, heating the material to extreme temperatures until it glows brightly across the electromagnetic spectrum. But the Cartwheel's black hole has always been an enigma, quiet when it should be ravenous, dim when it should blaze. Now, these erratic flickers suggest it might not be dormant after all, but obscured, hidden behind a shifting veil of cosmic debris. Picture a lighthouse shrouded by storm clouds, its beam only occasionally piercing through the gloom. The flickering could be a sign of instabilities in the black hole's accretion disk, the swirling maelstrom of matter spiraling toward oblivion. In most galaxies, this disk flows smoothly like water circling a drain. But in the Cartwheel, the disk might be fractured, fragmented by the galaxy's violent past. Gas and dust could be clumping unevenly, piling up in some regions while others run dry, creating bursts of light when chunks of material finally plunge into the black hole. It's like a malfunctioning conveyor belt, jamming and lurching forward in fits and starts. There's a wilder possibility, though. The flickering might not come from the black hole at all. Some astronomers argue these surges could be caused by stars, dozens, even hundreds of them, plunging into the galactic center in rapid succession. The Cartwheel's distorted arms and warped gravity could be funneling stars toward the core like marbles rolling down a tilted table. Each time one gets too close to the black hole, it's torn apart in a tidal disruption event, flaring brightly before vanishing. If true, the galaxy's core isn't just flickering, it's feasting, gorging on stellar flesh in a way we've never seen elsewhere. Yet even this grim explanation doesn't fully fit. The flickers are too frequent, too irregular to match the predictable timing of star consumption. That's led to a third, even more unsettling idea: magnetic reconnection. The Cartwheel's core could be threaded with magnetic fields so tangled, so knotted, that they periodically snap and rewire themselves, releasing colossal bursts of energy in the process. It's the cosmic equivalent of a rubber band stretched too far. Except when it snaps, it unleashes enough power to outshine entire star clusters. What makes this mystery so profound isn't just the flickering itself, but what it reveals about the Cartwheel's history. Galaxies are supposed to settle into equilibrium over time, their cores stabilizing as they age. But the cartwheel's heart refuses to calm, as if the collision that shaped it left wounds that never fully healed. Whether it's a hidden black hole, a shattered accretion disk, or something even stranger, one thing's clear. This galaxy isn't just defying expectations, it's teaching us how much we still have to learn about the turbulent lives of galaxies. Towering above the Cartwheel Galaxy's chaotic disk, like a halo tipped on its side, stretches a cryptic river of debris orbiting at a right angle to everything else. This isn't just scattered stardust, it's a polar ring, a vast, hoop-like structure of stars and gas spinning perpendicular to the galaxy's main plane, as if someone took a cosmic hula hoop and flung it around the cartwheel's waist. Polar rings themselves are rare enough, but this one's twisted, fragmented state tells an even wilder story. The aftermath of a near miss so violent it sent part of the galaxy spinning in an entirely new direction. Most polar rings form when a smaller galaxy collides at just the right angle, its material sheared off and captured into a stable orbit around the larger galaxy's poles. The cartwheel's version, though, is anything but stable. Instead of a smooth, cohesive ring, it's a tangle of stellar streams and gas clouds, some orbiting forward, some backward, as if multiple events wrenched the galaxy's fabric in opposing directions. The debris doesn't match the composition of any single intruder either. It's a patchwork of stellar ages and chemical signatures, hinting at not one, but multiple close encounters over billions of years. This chaos poses a glaring problem for astronomers. Our best simulations can't recreate it. When computers model galactic collisions, they typically produce clean, symmetrical polar rings, not this knotted mess. The cartwheel's debris suggests forces at work beyond standard gravity, perhaps involving dark matter interactions or magnetic fields powerful enough to torque an entire galaxy's orbit. Some researchers speculate the cartwheel might have been sideswiped by a galaxy rich in dark matter, its invisible halo twisting the cartwheel's structure like an invisible hand wringing out a towel. Others propose the polar ring is actually the mangled remains of two separate galaxies, each grazing the cartwheel at different times, their debris now braided together in an unstable dance. The most tantalizing clue lies in the debris's motion. Parts of the ring are collapsing inward, pulled back toward the cartwheel's core, while other sections are flinging outward, as if the system can't decide whether to coalesce or disintegrate. It's a snapshot of a galaxy caught between two destinies, one where the polar ring settles into place and another where it tears itself apart. That instability challenges our entire understanding of how galactic mergers unfold. If the cartwheel's polar debris defies prediction, how many other galaxies might be hiding similar anomalies? Their histories were written by collisions we don't yet understand. What makes this enigma so profound isn't just the debris itself, but what it reveals about the universe's untidiness. Cosmic collisions are messier, more creative, and less predictable than our simulations suggest. The cartwheel's lopsided halo isn't a flaw in the model, it's a challenge to build better ones, to account for the chaos that shapes galaxies in ways we're only beginning to glimpse. Among the Cartwheel Galaxy's many ghostly phenomena, few are as mesmerizing or as puzzling as its lingering light echoes. These are not ordinary remnants of exploded stars, but something far stranger. Shimmering rings of light, expanding outward like ripples in a pond, long after their parent supernova should have faded into darkness. Normally, such echoes vanish within decades as the light scatters into the void. Yet here, they persist for centuries, glowing faintly but stubbornly against the cosmic backdrop, as if time itself has slowed around them. It's like shouting into a canyon and hearing your voice echo back years later, defying every law of acoustics. The mystery lies in why these echoes last so long. When a massive star explodes, its flash of light races outward, illuminating dust and gas in its path. These illuminated patches, called light echoes, are typically brief cosmic camera flashes, here one moment and gone the next. But the cartwheel's echoes linger, their faint glow detectable long after similar echoes in other galaxies would have dissipated. One theory suggests the galaxy's interstellar medium, the soup of gas and dust between its stars, might be unusually dense or structured, acting like a hall of mirrors that traps and recycles the light. Picture a room lined with frosted glass, scattering light in every direction, keeping the glow alive far longer than it would in open space, but there's a catch. Denser dust should absorb more light, not prolong it. That's led to a counterintuitive idea. The cartwheel's dust might be arranged in vast, intricate shells or filaments, like layers of an onion, each one reflecting the light just enough to keep the echo alive without smothering it. Supporting this are infrared observations revealing bizarre, web-like structures in the galaxy's dust clouds, patterns far more organized than the chaotic swirls seen elsewhere. If these structures are real, they could be the universe's most efficient echo chambers, sculpted by shock waves from the galaxy's violent past. The most tantalizing possibility, though, is that we're seeing the aftermath of multiple supernovae. The cartwheel's frenetic star formation means massive stars die young and often, their explosions overlapping in time and space. One supernova's light echo might ignite another's dust cloud, creating a chain reaction of reflections that fool us into thinking a single echo has lasted centuries. It's like a row of dominoes made of light, each fall triggering the next, stretching the illusion of a single event far beyond its natural life. What makes these echoes truly extraordinary isn't just their longevity, it's what they reveal about the cartwheel's hidden architecture. Light echoes are cosmic X-rays, illuminating the galaxy's invisible scaffolding in ways ordinary starlight cannot. By studying their paths, astronomers have mapped pockets of gas so dense they defy physics, magnetic fields twisted into knots, and even hints of dark matter's gravitational fingerprints. The cartwheel's echoes aren't just ghosts of the past, they're flashlights in the dark, revealing a universe far stranger than we ever imagined. The Cartwheel Galaxy doesn't just bend light and stars, it twists the very fabric of space itself with magnetic fields so contorted they resemble a cosmic ball of yarn after a cat's play session. Unlike the orderly, spiral-shaped magnetic fields of most galaxies, where invisible lines gracefully follow the curve of stellar arms, the cartwheels are chaotic, knotted, and at times bizarrely inverted. Some regions flare with magnetic intensity strong enough to crush atoms, while others are eerily silent, as if the galaxy's magnetic heartbeat skips without warning. This isn't just a quirk. It's a glaring sign that the cartwheel operates by a different set of rules, its invisible forces sculpted by a history of violence we're only beginning to decode. The origins of this magnetic mayhem likely trace back to the galaxy's catastrophic collision. When that smaller galaxy plowed through its core, it didn't just rearrange stars, it sent shockwaves rippling through the cartwheel's magnetic architecture, warping and braiding it into configurations unlike anything seen in common galaxies. Picture a magnet dropped into a whirlpool, its field lines stretched, snapped, and rewoven by the churning water. That's what happened here, except the whirlpool is a galaxy-sized maelstrom of ionized gas, and the magnets are forces powerful enough to steer entire nebulae. Yet the chaos doesn't stop there. Radio telescope observations reveal something even stranger, patches where the magnetic field abruptly flips polarity, like a cosmic switch being flicked. In most galaxies, such reversals are rare and gradual. Here, they're sharp and localized, as if hidden hands are tampering with the galaxy's electromagnetic blueprint. One theory points to rogue black holes, not just the supermassive one at the core, but smaller, wandering ones left behind by the collision. As these invisible predators plow through the galaxy's gas, their gravity could twist magnetic fields into knots, creating pockets of instability where the rules of electromagnetism temporarily short-circuit. The most tantalizing clue, though, lies in the galaxy's outer ring. While the inner regions simmer with magnetic turbulence, the ring itself hosts filaments of organized field lines, strangely aligned along its curvature like threads in a spiderweb. These filaments shouldn't be able to maintain coherence amid the chaos, yet they do, almost as if the ring is generating its own magnetic stability. Some astronomers speculate this could be evidence of a dynamo effect, a self-sustaining magnetic engine fueled by the ring's furious star formation. As newborn stars pump energy into their surroundings, their winds and supernova might be weaving these orderly patterns into the galaxy's fabric, a rare example of creation arising from destruction. But the real enigma is what these twisted fields mean for the Cartwheel's future. Magnetic fields shape how galaxies evolve, guiding gas flows and star formation. If the Cartwheel's fields are this disordered, it could be locking itself into a cycle of perpetual turbulence where gas can't settle evenly and stars are born in erratic bursts. Alternatively, the knots might unravel over eons, smoothing into a new equilibrium, one we've never seen elsewhere. Either way, the Cartwheel's magnetic tantrum is more than a curiosity. It's a laboratory for the most extreme physics, proving that even the universe's invisible forces can be bent, broken, and reborn. The Cartwheel Galaxy spins in eerie cosmic solitude, its vibrant rings unaccompanied by the usual entourage of dwarf galaxies that should orbit it like loyal attendants. In nearly every other corner of the universe, massive galaxies like this one are surrounded by swarms of smaller satellites, remnants of the primordial soup from which they formed. Yet around the Cartwheel, the void yawns empty, as if some unseen force has scrubbed the neighborhood clean. This absence isn't just unusual, it's a direct challenge to our understanding of how galaxies grow and evolve. Where did the satellites go, and what does their disappearance reveal about the Cartwheel's violent past? The mystery begins with the standard model of galaxy formation, which predicts that colossal structures like the Cartwheel should have dozens of dwarf galaxies in their gravitational grip. These satellites are cosmic fossils, the leftover building blocks from the galaxy's assembly over billions of years. Their absence here is like finding a towering castle with no surrounding village, a glaring omission that hints at a story missing from the textbooks. One possibility is grimly straightforward: the Cartwheel devoured them. Galactic collisions don't just reshape their participants, they're cosmic feeding frenzies, with larger galaxies tearing apart and absorbing smaller ones. If the Cartwheel's ancient collision was particularly messy, it might have shredded every satellite in its path, leaving behind only faint stellar streams as evidence of its feast. But there's a catch. Even the most voracious galaxies typically leave a few survivors, tiny dwarfs clinging to the outer edges like timid onlookers. The Cartwheel's emptiness is too complete, too absolute for this to be the whole story. That's led to a more radical idea. Perhaps the satellites were never there to begin with. Some simulations suggest the Cartwheel might have formed in a region of the universe unusually sparse in dark matter, the invisible scaffolding that helps dwarf galaxies coalesce. Without enough dark matter to anchor them, the Cartwheels would-be satellites might have failed to form entirely, leaving the galaxy to grow up alone in a cosmic desert. The plot thickens when you consider the Cartwheel's neighbors. A handful of distant dwarf galaxies float on the periphery of its gravitational influence, but they're drifting away, not circling closer. Their motions suggest they're not true satellites but interlopers, passers-by briefly snagged in the galaxy's pull before continuing their journey into the void. This raises an even stranger possibility. The Cartwheel could be an immigrant, a galaxy that wandered into this quiet corner of space after forming elsewhere, leaving its original satellite family behind. If true, it would mean we're not just looking at a galactic oddity, we're witnessing a cosmic drifter, a lone wolf that somehow escaped the crowded dens where most galaxies reside. Then there's the dark matter paradox. If the Cartwheel lacks satellites because it lacks dark matter, how does it hold itself together? Dark matter is the universe's glue, the hidden force that keeps galaxies from flying apart under the spin of their own stars. Yet the Cartwheel's rings remain stable, its structure intact, defying expectations. Some astronomers speculate that the collision that shaped its iconic form might have redistributed dark matter in ways we don't yet understand, flinging it outward into a diffuse halo too thin to birth new satellites but still dense enough to bind the galaxy. Others wonder if we're seeing evidence of alternative physics, where dark matter behaves differently under extreme conditions, or isn't the dominant force at all. What makes this enigma so profound isn't just the missing dwarfs, it's what their absence tells us about the universe's unspoken rules. Galaxies aren't supposed to form without dark matter. They're not supposed to exist in isolation. The Cartwheel's defiance forces us to question whether our models are incomplete, or if this galaxy is the exception that proves an entirely new rule. Until we solve the riddle of its phantom satellites, the Cartwheel will remain a cosmic rebel, challenging us to rethink how galaxies live, grow, and sometimes stand utterly alone. Deep within the Cartwheel Galaxy's spiraling chaos, astronomers have pinpointed a patch of space where the universe seems to hold its breath, a region where stars hang motionless against the void, their usual dance frozen mid-step. They call it the glass zone, a place where time itself appears to slow, leaving stars suspended like insects trapped in amber. This isn't just an optical illusion or a trick of perspective. Measurements confirm these stars are moving at a fraction of the speed they should be, as if some unseen force has pressed pause on the laws of physics. The anomaly becomes even stranger when you consider the stars' positions. They aren't clustered or isolated but scattered across a vast, irregular swath of the galaxy's outer ring, mingling with normally moving neighbors. It's as if someone drew an invisible boundary and said, "Inside here, the rules change. Traditional explanations fall short. Gravitational drag from dense gas clouds would slow stars unevenly, not in unison. A hidden mass like a rogue black hole would warp their motions into curves, not lock them in place. Even dark matter, the universe's usual culprit for odd gravity, typically accelerates stars, not freezes them." One radical theory points to gravitational dead zones, regions where the fabric of space-time has been stretched so thin by the galaxy's collision that it behaves like cosmic molasses, resisting motion like a swimmer fighting against tar. Picture throwing a ball into a vat of honey. It moves but sluggishly, as if the air around it has thickened. If the Cartwheel's ancient impact warped space-time in just the right way, it could have created pockets where gravity's pull is offset by an equal, opposing drag, leaving stars in eerie equilibrium. Then there's the illusion hypothesis. What if the stars are moving normally, but something between us and them is bending light to create a false snapshot? The galaxy's turbulent magnetic fields could be acting like a funhouse mirror, distorting starlight so severely that their proper motion, their true path across the sky, is masked. It's the cosmic equivalent of a strobe light in a dark room, where rapid flashes make a spinning fan appear motionless. If the Cartwheel's magnetic fields are pulsing in sync with the star's orbits, they might cancel out all signs of movement to distant observers. But the most unsettling possibility is that we're seeing a glitch in the universe's clockwork. Some models of quantum gravity suggest space-time isn't perfectly smooth but pixelated, made of minuscule loops or grain. Under extreme conditions like those in a post-collision galaxy, these grains might align in a way that locally alters time's flow. The stars in the glass zone wouldn't feel slower. To them, everything outside their bubble would appear to speed up. It's a cosmic version of relativity's twin paradox, where time itself becomes malleable. What makes the glass zone more than a curiosity is what it implies about the Cartwheel's role as a laboratory for extreme physics. If space-time can be warped to this degree, even temporarily, it hints at phenomena we've only theorized: wormholes, warp bubbles, or dimensions beyond our perception. Whether it's twisted gravity, light's illusion, or a crack in time's foundation, one thing's certain: in the Cartwheel Galaxy, even stillness screams with secrets. From the Cartwheel Galaxy's shadowy outskirts, a signal crackles across the cosmos, a fast radio burst, or FRB, erupting with the energy of a billion suns in just milliseconds. But this isn't a one-time cosmic shout. It's a recurring message, a pattern of bursts repeating at intervals that defy natural explanation. Most FRBs flash once and vanish, their origins lost to the void. These, however, return like clockwork, pulsing from the same patch of sky near the Cartwheel's fractured edges, as if something or someone is tapping out a rhythm against the fabric of space. Astronomers first dismissed recurring FRBs as flukes, glitches in the universe's static. Then they found more, all following eerie, non-random patterns. The Cartwheel's bursts are among the most enigmatic, flaring with a precision that straddles the line between natural phenomenon and engineered signal. The leading theory points to magnetars, neutron stars with magnetic fields so intense they could crush atoms into ribbons. When these cosmic powerhouses undergo starquakes, their crusts shatter, releasing bursts of energy that ripple across the electromagnetic spectrum. The Cartwheel's turbulent history makes it a magnetar factory, its violent star-forming regions birthing these unstable beasts in droves, yet the timing doesn't quite fit. Magnetar flares are chaotic, their bursts unpredictable. The Cartwheel's FRBs, however, sometimes arrive in sequences so regular they resemble a cosmic metronome. One series, detected over 2 years, pulsed every 160 days on the dot. No known stellar process keeps a schedule this precise. That's led to whispers of more exotic explanations, colliding neutron stars wrapped in magnetic braids, or black hole jets slicing through plasma clouds at just the right angle to create a lighthouse effect. Then there's the elephant in the room: artificial origins. The notion that these bursts could be engineered, perhaps by an advanced civilization, lingers at the fringe of plausibility. After all, humanity itself has broadcast intentional radio signals into space for over a century. Could the Cartwheel's FRBs be something similar? Most scientists remain skeptical, citing the staggering energy required. Each burst emits more power than our sun does in decades. But the universe is vast, and the line between natural and unnatural blurs when physics reaches such extremes. What makes these FRBs truly unsettling is their location. They emanate from the Cartwheel's halo, a region where stars are sparse and gas clouds drift like ghosts. There's no visible source, no smoking gun of a magnetar or black hole. Just empty space crackling with bursts of energy that arrive like clockwork, then vanish without a trace. It's as if the galaxy itself is harboring a secret, one it only whispers when the cosmos is listening. Whether natural or not, these repeating FRBs challenge our understanding of how energy behaves in the universe's most extreme environments. Every time they repeat, they carve a deeper groove in the mystery surrounding the Cartwheel Galaxy, a groove that might one day lead us to answers or to questions we've yet to dream of. Amid the Cartwheel Galaxy's swirling arms, a celestial mirage shimmers into view, a vast, glittering cloud dubbed diamond dust, its metallic particles scattering light with uncanny precision. Unlike ordinary nebulas which glow with diffuse gas, this structure sparkles like a cosmic disco ball, reflecting starlight in sharp, geometric patterns. At first glance, it resembles the aftermath of a supernova, where dying stars spew heavy elements into the void, but the chemistry here is all wrong. The dust isn't just rich in carbon and silicon, it's laced with exotic metals like titanium and zirconium, forged under conditions so extreme they defy typical stellar furnaces. The leading theory points to a recent supernova, one so violent it vaporized a nearby asteroid belt or dwarf planet, blasting its metallic guts across light years of space. When massive stars explode, they seed their surroundings with elements cooked in their cores, but the diamond dust cloud's composition suggests something rarer. Its particles are unnaturally uniform in size, as if sieved by an invisible cosmic filter, and their crystalline structure reflects light with near-perfect symmetry. It's the difference between scattering sand and scattering precision-cut gems. Some astronomers speculate this could be the signature of a Type Ia supernova, the kind that occurs when a white dwarf star detonates after siphoning material from a companion. Such explosions are known to produce heavy metals in abundance, but even they struggle to explain the cloud's eerie homogeneity. Then there's the location problem. The diamond dust floats unusually far from any obvious stellar wreckage, adrift in a region where no recent supernova remnants have been detected. This has led to a wilder hypothesis. The cloud might be the corpse of a collapsed neutron star merger. When these ultra-dense stellar remnants collide, they forge gold, platinum, and other heavy elements in staggering quantities, enough, perhaps, to coat an entire nebula in metallic splinters. Supporting this idea are faint gravitational wave echoes detected near the Cartwheel years ago, hints of a cataclysm that might have birthed this glittering anomaly. But the real enigma lies in the cloud's behavior. Instead of dispersing or clumping under gravity, the diamond dust maintains its structure, its particles repelling each other almost magnetically. Some researchers suggest the grains could be electrically charged, their surfaces ionized by radiation from the Cartwheel's frenzied star-forming regions. Others wonder if dark matter is at play, its invisible tendrils weaving through the cloud, sculpting it into this improbable formation, the most tantalizing clue. The cloud's light patterns shift over time, flickering in sync with the galaxy's radio bursts. It's as if the diamond dust isn't just a passive reflector, but an active participant in the Cartwheel's chaos, a cosmic mirror turning to face some unseen spotlight. Whether it's the ghost of a stellar explosion, the debris of a neutron star crash, or something even stranger, one thing's clear: this isn't just dust. It's a metallic whisper from the universe's most violent forges, a reminder that even in destruction, there's beauty and mystery sparkling in the dark. Somewhere in the Cartwheel Galaxy, gravity itself seems to be playing tricks, pockets of space where stars accelerate unexpectedly, bending their paths as if tugged by invisible hands. These aren't your typical gravitational anomalies caused by dense star clusters or hidden gas clouds. Instead, they're eerie regions where the pull of gravity far outweighs what visible matter could possibly account for. Imagine throwing a ball and watching it suddenly veer midair, yanked by a force with no source. That's exactly what's happening here, and astronomers are scrambling to figure out why. One compelling suspect: primordial black holes, ancient relics theorized to have formed in the earliest moments of the universe, long before stars or galaxies took shape. Unlike the black holes born from collapsing stars, these would be far smaller, some no heavier than a mountain yet as compact as an atom. Their extreme density would let them punch far above their weight, exerting gravitational influence disproportionate to their size. If the Cartwheel harbors a swarm of these invisible predators drifting through its outer reaches, they could explain the galaxy's phantom gravity wells without leaving a trace of light or radiation. Then there's the space-time angle. The Cartwheel's violent collision might have warped the fabric of the universe around it, creating folds or wrinkles where gravity intensifies unexpectedly. Picture a bedsheet stretched taut, pressed down in one spot, and nearby objects roll toward the dent. If the galaxy's impact left similar distortions in spacetime itself, these gravity wells could be cosmic potholes, invisible dips in the road where stars and gas clouds naturally slow or curve. Supporting this idea are strange patterns in the galaxy's outer ring, where star streams appear to converge at points with no visible mass, as if funneled by hidden contours in space. But the most radical possibility is that we're seeing shadows of extra dimensions. Some unified physics theories suggest gravity could leak into higher dimensions beyond our perception, weakening its force in our visible universe. In regions where this leakage is uneven, where dimensions overlap or pinch, gravity might briefly surge back to full strength, creating localized pockets of intensity. The Cartwheel, with its turbulent history, could be riddled with these dimensional cracks, its gravity wells marking spots where the universe's hidden geometry briefly peeks through. What makes these anomalies so unsettling is their unpredictability. Unlike black holes or dark matter clumps which follow rough patterns, the Cartwheel's gravity wells appear and vanish over time, as if flickering in and out of existence. Some linger for centuries, distorting everything around them. Others flare up for mere decades before fading back into the cosmic background. It's as if the galaxy is testing different gravitational rules in different corners, teasing us with glimpses of physics we don't yet understand. Whether they're primordial black holes, space-time scars, or something even stranger, one thing's clear: the Cartwheel's invisible gravity wells are more than cosmic quirks. They're breadcrumbs leading us toward deeper truths about how mass, energy, and the universe's hidden layers intertwine. And until we solve their riddle, they'll remain silent reminders of how much gravity, the force we think we know best, still has to teach us. Tucked away in one of the Cartwheel Galaxy's spiral arms, a nebula pulses with a rhythm so precise it could be mistaken for a cosmic symphony. Dubbed the Singing Nebula, this glowing cloud of ionized gas doesn't just emit random radio noise, it broadcasts a series of harmonic frequencies that align eerily with the mathematical ratios found in human music. The pulses rise and fall in pitch, creating a pattern that mirrors the cadence of a song, as if the universe itself had tapped into some universal language of sound. What makes this phenomenon so baffling isn't just the rhythm, it's the source. Nebulas typically hum with chaotic energy, their radio emissions a static hiss of charged particles colliding in turbulent clouds. But here, the vibrations are orderly, almost orchestral. The leading explanation points to plasma waves, ripples in the nebula's electrified gas, triggered by the shock waves of nearby supernova or the gravitational tug of hidden neutron stars. As these waves travel through the nebula's magnetic field, they could be compressing and rareifying the plasma in rhythmic cycles, like air vibrating through a flute. Yet the precision defies coincidence. Some of the frequencies match harmonic intervals found in Earth's musical scales, resonating at ratios like the perfect fourth or fifth, the same intervals that give symphonies their emotional pull. Astronomers have even identified sequences that resemble repeating motifs, as if the nebula is composing its own celestial fugue. Is this a fluke of physics or something deeper? One theory suggests the nebula's shape, a vast hollow bubble, might be acting as a natural resonance chamber, amplifying certain frequencies while dampening others, creating a filtering effect that turns chaos into melody. Then there's the wild card, magnetars. These highly magnetized neutron stars, known for their erratic energy bursts, could be plucking the nebula's magnetic fields like guitar strings, generating pulses that echo through the gas. If one lurks nearby, undetected, its periodic eruptions might be the unseen conductor behind this cosmic chorus. But the most haunting possibility is that we're hearing the nebula's death song. As the cloud expands and dissipates, its vibrations could be slowing, like a record player winding down with the music fading into silence. Or perhaps it's a birth cry, a lullaby for the new stars forming within its glow. Either way, the Singing Nebula reminds us that the universe isn't just a silent void, it's a symphony waiting to be heard, if only we know how to listen. Among the Cartwheel Galaxy's many optical illusions, one stands out as particularly mind-bending: light that appears to slow down as it travels toward us. Astronomers call this time-dilated light, where certain wavelengths stretch inexplicably, arriving redshifted beyond what the galaxy's motion should account for. It's as if pockets of space within the Cartwheel are resisting the light's journey, forcing it to trudge through cosmic molasses before reaching our telescopes. The anomaly becomes clear when mapping the galaxy's spectral lines, the unique fingerprints elements leave in starlight. Normally, these lines shift predictably based on an object's velocity, stars moving away from us appear redder while those approaching look bluer. But in the cartwheel, some regions exhibit redshifts that don't match their actual motion. Stars that should be racing toward us at hundreds of kilometers per second appear sluggish, their light stretched as if space itself is fighting their momentum. One explanation points to dark energy, the mysterious force accelerating the universe's expansion, acting unevenly within the galaxy. If dark energy's repulsive gravity varies locally, it could create pockets where space stretches more aggressively, elongating light waves mid-flight. Picture a marathon runner suddenly hitting a stretch of uphill road. Their pace slows even if their effort doesn't. Similarly, photons struggling against intensified dark energy would lose energy, redshifting without any change in the source's actual velocity. Then there's the measurement problem. The cartwheel's chaotic structure might be fooling our instruments. Gas clouds rich in iron or silicon could absorb specific wavelengths, mimicking redshift where none exists. Or perhaps foreground objects in visible dwarf galaxies or dark matter clumps are gravitationally lensing the light, bending its path in ways that distort our perception of its speed. It's like watching a car through a funhouse mirror. The reflection twists, but the car itself moves normally. The most tantalizing possibility, these anomalies might be relics of the galaxy's collision. When the smaller galaxy punched through the cartwheel's core, the impact could have sent shockwaves rippling through spacetime, leaving behind regions where time flows subtly slower. Light escaping these zones would emerge stretched, carrying the imprint of distorted time. Einstein predicted this gravity's ability to warp time, but seeing it etched into an entire galaxy's light would be unprecedented. What makes this phenomenon so profound isn't just the mystery, it's the implications. If dark energy or warped time can tweak light's behavior on galactic scales, it could rewrite how we measure cosmic distances, alter our understanding of the universe's expansion, and even hint at physics beyond Einstein's equations. Until we solve the riddle, the cartwheel's time-dilated light remains a cosmic stopwatch, ticking at a rhythm we don't yet understand. Scattered across opposite sides of the Cartwheel Galaxy, two star clusters glow like cosmic twins, identical not just in size and brightness, but in the very DNA of their stellar populations. When astronomers first analyzed their spectra, they expected subtle differences in age, composition, or chemical fingerprints. Instead, they found a perfect match, the same ratio of blue supergiants to red dwarfs, the same abundance of heavy metals, even the same peculiar stellar outliers. It's as if someone cloned a cluster and placed the copy hundreds of light years away, defying the natural variability we see everywhere else in the universe. This mirroring poses a profound puzzle. Star clusters are born from collapsing gas clouds, and no two clouds are chemically identical. Even within a single galaxy, variations in initial conditions, tiny differences in turbulence, density, or nearby supernova pollution leave distinct marks on the stars that form. Yet these twin clusters share every detail, down to their rarest stellar oddities. Hypervelocity stars racing toward escape velocity, binary systems locked in unusually tight orbits, even the same distribution of ancient metal-poor relics. The odds of this happening by chance are astronomically low, akin to finding two forests where every tree is the same species, height, and age despite growing miles apart. The leading theory suggests they were once one. During the Cartwheel's catastrophic collision, a massive star cluster might have been torn in half by tidal forces, its stars sheared into two streams that later recoalesced into separate but identical groups. Computer simulations show this is possible if the original cluster was unusually dense, its gravitational bonds strong enough to keep most stars together even as the galaxy's gravity ripped it apart. Think of a globular cluster stretched like taffy until it snaps, with each half retaining the same stellar ingredients as it reshapes into a new sphere. But there's a catch. The twin clusters aren't just chemically alike, they're also the same age, roughly 800 million years old. That's too young for a globular cluster, which typically date back to the universe's infancy, and too old to have formed during the Cartwheel's collision, which reshaped the galaxy a mere 200 million years ago. This timeline mismatch hints at a stranger origin. Perhaps the clusters were born together from the same gargantuan gas cloud, one so uniform it spawned twin stellar nurseries simultaneously, then drifted apart before their stars ignited. The implications ripple outward. If star clusters can form or fracture into perfect copies, it challenges our assumptions about how cosmic structures diversify. The Cartwheel's twins might be extreme outliers, or they could represent a common but overlooked phenomenon in violently reshaped galaxies. Every new observation deepens the mystery, proving that even in the chaos of colliding galaxies, the universe has a way of leaving behind echoes perfect, uncanny, and utterly inexplicable. But perhaps the most haunting mystery of the Cartwheel Galaxy isn't something within it, it's the ghost lurking behind it. Radio telescopes have detected a faint, ethereal echo of the galaxy hovering just beyond its visible edges, a near-perfect duplicate in radio wavelengths, as if someone had placed a cosmic tracing paper over the Cartwheel and sketched its outline in invisible ink. This shadow galaxy doesn't appear in optical or infrared light. It exists only as whispers in the radio spectrum, its gossamer structure mirroring the Cartwheel's spiral arms and broken ring with unsettling precision. The leading explanation bends the mind as much as it bends light. Astronomers suspect this phantom might be the Cartwheel's own radio emissions, warped and magnified by an invisible gravitational lens. A supermassive object, likely a foreground galaxy cluster, floating between us and the Cartwheel. Einstein's theory of general relativity predicted this effect. Massive objects curve spacetime so profoundly that light and radio waves traveling past them gets diverted, like a marble rolling around the rim of a funnel. The result, a natural cosmic projector capable of creating multiple, distorted copies of background objects. What makes this shadow so eerie is its incompleteness. Unlike typical gravitational lenses, which produce stretched arcs or smeared Einstein rings, this one has crafted something unnervingly faithful to the original, almost like a watercolor copy where only certain pigments bled through. The radio waves outlining the Cartwheel star-forming regions appear crisp, while emissions from its quieter zones vanish entirely. Some theorists suggest this selectivity implies the lensing object isn't just massive, it's structured in a way that acts like a celestial stencil, allowing only specific wavelengths or angles of light to slip past its gravitational grip. The shadow's existence hints at something even more profound. We might be seeing the Cartwheel twice. If the lensing object is perfectly aligned, some of the galaxy's light could take multiple paths around it, arriving at Earth at slightly different times. That means the shadow could be a delayed echo, a glimpse of the Cartwheel as it existed hundreds of thousands of years ago, superimposed over its present-day self. The implications are staggering. By comparing the two, astronomers could effectively study the galaxy's evolution in real time, watching how its star-forming regions have shifted or dimmed over cosmic timescales. Yet the biggest enigma remains the lens itself. Despite exhaustive searches, no visible galaxy cluster has been found at the shadow's predicted location. This leaves two spine-tingling possibilities. Either the lens is a vast, nearly invisible cloud of dark matter, so dense it bends light but emits none, or we're witnessing a new kind of gravitational lensing, one where the warping isn't caused by a single object, but by a ripple in spacetime itself, frozen in place since the universe's violent infancy. Whether it's dark matter's fingerprint or a wrinkle in the fabric of reality, the Cartwheel's shadow forces us to confront an unsettling truth. Even when we study a galaxy's light, we might only be seeing half the story. The rest could be hiding in the darkness, waiting for the right tools and the right cosmic alignments to step into view. Just when you think the Cartwheel Galaxy can't defy logic any further, it pulls off its greatest trick, yet entire sections of its spiral arms vanish without a trace when viewed through certain telescopes. One moment they're there, glowing vividly in visible light. Switch to infrared or radio wavelengths and they're gone, as if someone flipped a cosmic light switch. This isn't just an optical illusion or a trick of perspective. These regions aren't merely dimmed, they're erased, leaving behind voids so absolute that astronomers initially assumed their instruments had malfunctioned. The prime suspect, interstellar dust, but not the ordinary kind. Most cosmic dust is like fine, sooty powder, scattering or absorbing light predictably across wavelengths. The Cartwheel's dust behaves more like a celestial invisibility cloak, engineered to vanish at specific frequencies. Some patches are so dense they block all visible light, yet turn eerily transparent in infrared. Others seem to selectively filter out radio waves while remaining opaque to X-rays. It's as if the galaxy's dust clouds have been custom-tuned to interact with light in ways no natural process should allow. One theory blames the galaxy's violent collision. When that smaller galaxy plowed through its core, the shockwaves might have compressed dust grains into exotic, fractal shapes, snowflakes of carbon, and silicate with intricate geometries that scatter light unpredictably. Laboratory experiments show that under extreme pressure, dust can form layered, razor-thin structures that act like microscopic prisms, bending certain wavelengths into oblivion. If true, the Cartwheel's disappearing act could be a fluke of physics, a rare alignment of chaos and geometry we've never witnessed elsewhere. Then there's the wild card, magnetic shadows. The Cartwheel's tangled magnetic fields are powerful enough to reshape how dust particles align. If these fields have organized the dust into vast, swirling curtains, all their jagged edges pointing the same direction, they could be polarizing light, effectively canceling out specific wavelengths entirely. Imagine holding a picket fence up to the sun, tilt it just right, and the gaps between the planks let light through in slivers. Tilt it again, and the planks themselves block the view. The Cartwheel's magnetic fences might be doing the same thing, but on a galactic scale. But the most unsettling possibility isn't dust or magnetism, it's absence. Some vanishing regions show no dust at all, no gas, no trace of anything that should obscure light. They're just empty. Astronomers have dubbed these zones void pockets, and their leading hypothesis is chilling dark matter. Not the diffuse halo kind, but rogue clumps of invisible particles so dense they warp space-time itself, bending light away from our telescopes like a cosmic mirage. If these clumps exist, they wouldn't just hide parts of the galaxy, they'd distort our entire perception of its structure, turning the Cartwheel into a hall of mirrors where some reflections are missing entirely. What makes this phenomenon so profound isn't just the mystery, it's what it reveals about how little we truly see. The universe isn't just made of what glows or reflects. It's woven from shadows, from absences, from forces that edit themselves out of the picture. The Cartwheel's disappearing act forces us to question not just what's there, but what isn't, and why the cosmos sometimes chooses to hide its most dazzling secrets in plain sight. The Cartwheel Galaxy isn't just another pinwheel of stars, it's a cosmic hall of mirrors, bending the rules of physics with every twist of its fractured arms. From the eerie synchronicity of its spinning neutron stars to the ghostly whispers of its missing dark matter, this galaxy refuses to play by the universe's playbook. It's a place where time itself stutters in the glass zone, where stars vanish into dust's invisible clutches, and where radio bursts pulse with the precision of a metronome. The Cartwheel's shadowy double, its Singing Nebula, even its inexplicably identical star clusters. Each phenomenon peels back another layer of cosmic mystery, revealing how much we still don't understand. Think about it, a galaxy that shouldn't exist in this form, its perfect ring frozen in time, its black hole inexplicably silent while rogue stars race through its outskirts like cosmic fugitives. It challenges our assumptions about how galaxies age, how stars form, and even how gravity itself operates. The cartwheel isn't just an outlier, it's a laboratory for the universe's most extreme experiments, a place where the ordinary becomes extraordinary and the impossible becomes routine. But here's the real kicker. Every time we think we've cracked one of its enigmas, the cartwheel throws us another curveball. Those gamma-ray hotspots with no source, the polar ring orbiting at right angles like a cosmic hula hoop, the way entire sections of its arms blink out of existence depending on how we look at it. These aren't just quirks, they're clues, hinting at forces and phenomena we've yet to name. So what's your favorite mystery? The phantom gravity wells tugging at stars, the diamond dust cloud glittering with forged metals, or maybe the way this galaxy seems to hold entire chapters of cosmic history in its warped, rippling rings? Drop your pick in the comments, and while you're there, let us know which cosmic oddity we should explore next, because the universe is full of cartwheels, each one daring us to look deeper, question harder, and marvel at how much stranger reality is than we ever imagined. Don't forget to subscribe so you don't miss the next deep dive into the unknown. After all, the cosmos never runs out of surprises, and neither do we.